This is a tutorial on the Hoek-Brown failure envelope or failure criterion for intact rock based on lab testing on core specimens. So this is a relatively straightforward example, but I just wanted to take you through it. The following data was obtained from triaxial testing on some Wallace sandstone on 50 millimeter diameter cores, and the data is listed here in this table, and we're asked to plot it in sigma 3, sigma 1 space, which is the typical space that we use for plotting failure criterions in rock engineering. And then we're asked to determine the parameters that describe the failure envelope for the intact rock and make some comments on it. So if you'll remember our analysis of UCS test data, there was some problems with the data. So it is important to spend at least a few minutes to look at the data and see if there's anything abnormal right off the bat. Now, typically in these kind of lab tests, we also take photographs of before the specimen is broken and after the specimen is broken, and those photographs can also be inspected to give you some advice about the validity or any problems with testing. So there doesn't seem to be anything here, and we have, you can see sigma 3 is the confining stress in the triaxial cell. So remember, we have a triaxial cell here, and we'll have a sigma 1, and sigma 3 acts all around as a confining stress. Okay, so we have results for confining stresses at 5 MPa, 10 MPa, 15 MPa, and up to 20 MPa. And we have a various sigma 1s at failure. So these are the peak stresses. Okay, so first off, let's plot it in sigma 1 and sigma 3 space. Okay, so here we go. And you can see that, that we have groupings for each confining stress range. And really, this data is remarkably well behaved. Probably too well behaved to be of interest, but we'll do what we can. But I'll caution you, in reality, you know, it's not uncommon for you'd have some kind of unusual data point or two out of that has to be more carefully looked at. All right, so we want to fit our Hoek-Brown criterion, and when we want to come up with some parameters that describe it, well, let me just remind you of the Hoek-Brown failure criterion. Okay, so sigma 1 is equal to sigma 3 plus sigma c, the unconfined compressive strength, right? Okay, so that's the UCS test. Okay, times the square root of a parameter mi, sigma 3 over sigma c, plus 1. Okay, so in the more general form of the Hoek-Brown criterion, might look like this, plus sigma c, and then we'll have a bracket mi over sigma 3 over sigma c plus s. And this is A, okay, right? So really what we're just saying here is A is equal to 0.5 and S is equal to 1, and you have the same results. So these are the standard values for intact rock. All right, so really we need to come up with Mi is really the only parameter that we So what is typically done is the data is used for a regression to come up with our value of MI. Actually, come to think of it, we also don't have the UCS value. We don't have the UCS value. Now, we may have a bunch of UCS data already that we can use to come up with a recommended UCS value for this. But my understanding is the latest version of the Hoek-Brown criterion in a paper in 2018 by Hoek and Martin, they recommended that actually for the criterion that the value of sigma c over here should really be based on this regression. As opposed to getting it directly from the lab tests. Okay, so there's different kinds of regression algorithms that are being proposed, but here is the simplest one we're going to use, and this is right out of Hook's notes, or Practical Rock Engineering by Everett Hook. And in order to do the regression, he proposed to transform the Hoek-Brown function into a different format. Okay, so here's the Hoek-Brown equation, and instead he makes a transformation where x is equal to sigma 3 and y is equal to the deviatoric stress sigma 1 minus sigma 3 squared, and then fitting that into an equation of this form. Okay. Oh, and by the way, you'll note the little ticks here to denote effective stresses. So after that, you can use after this transformation, you can use these equations below to come up with regression-based values for the unconfined compressive strength. And you'll notice he's using sigma ci back then, but really we are talking about sigma c, which is the result of unconfined compressive strength values. And here we have mi, and again the sigma c in this is also the same. And we have an r squared value so that we can assess the quality of our fit and our parameters. So they're kind of involved equations. I'm not going to calculate them here for you. You want to use a computer, you want to use Excel or MATLAB or something along those lines. And in Hook's book, Practical Rock Engineering, he actually lays out an Excel sheet with all the formulas and all the steps in order to do this regression. So that is a very straightforward approach, and I more or less use that approach to calculate the parameters and to plot it. Oh, I should also let you know that there is a software called Rock Data. Rock Data. And that is a rock science software that comes with our rock science suite, and that can be used to enter this triaxial data and come up with the parameters as well. Okay, so on the basis of this regression approach, I was able to come up with some values. Okay. And this is the same data with the failure criterion plotted alongside of it. And based on that regression, I had an unconfined compressive strength of 89.4 MPa. The A and S values are already standard for intact rock tests of 0.5 and 1. From the regression, most importantly, we got an MI value of 12.1. That's really the major parameter that we're going to get. And we had a, oops, that's should be an uppercase. we have an R squared value of 0.71, and that indicates a pretty good quality fit. Not tremendous though. You can see there clearly is some spread for each confinement level, but truly the data is very well behaved, and using your judgment, you can see that that is a pretty decent envelope. So that's how you carry out that exercise and come up with your intact parameters. And that's an important first step for later on looking at the rock mass version of the Hoek-Brown criterion. Thank you.